Hey everyone, welcome to the net change as the integral of a rate. We're going to be looking at a couple of examples of what net change is and how it relates to integrals. This is Nicholas JMV. So when we talk about net change, the net change in a function s of t over a given interval, and this interval is from t1 to t2, it's given by this integral. So the integral from t1 to t2 of s prime of t dt, and that's going to equal s of t sub 2 minus s of t sub 1. So here's the net change, and here's the integral of the rate of change. So that's what we're going to be concentrating on today. And notice how to find the net change, it's s of t sub 2 minus s of t sub 1, that idea of the fundamental theorem of calculus. So this is kind of the idea of the whole lesson today, okay? So let's go ahead and look at our first example. Water leaks from a tank at a rate of 2 plus 5t liters an hour, where t is the number of hours after 7 a.m. How much water is lost between 9 and 11 a.m.? Okay, so the first thing we got to do is we're going to define S of t. Now, S of t is going to be the quantity of water. So that's the quantity of water at time t. Okay, we need to know that. Okay, that's our first thing. Okay, secondly, we know that s prime of t, the integrand, okay, is going to be equal to the negative of 2 plus 5t. And the reason why it's negative here is because the water's leaking out, it's decreasing, it's leaving this tank, so that should be negative. Okay, and we also know that t is going to be between 2 and t is going to be between 4, okay, because we're looking at the time after 7 p.m. 9 is 2 hours after 7 p.m., so t equals 2, and then 11 a.m. is 4 hours after, so t is going to be 4. Okay, so we're going to look at what's the change, how much is leaving. So the idea here is we're going to be looking s sub 4 minus s sub 2. That's going to equal, okay, this integral. So the net change, how much water came out during that time, is going to be equal to the integral from 2 to 4 of s prime of t dt, okay? And that's going to equal the integral from 2 to 4. S prime of t is negative 2 plus 5t dt, okay? And then when we bring the negative out front, okay, and we take the integral here, we're going to have 2t plus 5 halves t squared, and we got to evaluate that from 2 to 4. Okay, so when we plug 4 into all of this, we get negative 48 minus, so basically s sub 4, right, minus s sub 2, which is negative 14. So our answer becomes negative 34 liters. So the net change, okay, over that interval, S of 4, between 9 and 11 is going to be 34 liters, negative 34, because it's decreasing, it's leaving. Okay, so that's our first example. Let's look at our second example. A lot going on here, a lot of words, but we'll get through it pretty quick. The number of cars per hour passing an observation point along a highway is called the traffic flow rate, Q of t, in cars per hour. Part A, which quantity is represented by the integral of t sub 1 to t sub 2 of Q of t. Okay, so we got to basically interpret this, the first thing we're going to do. Okay, and so in part A, this integral from t sub 1 to t sub 2 of Q of t, okay, dt, okay, that's going to represent the total number of cars. So this is equivalent, they're saying the total number of cars that pass the observation point. Okay, that's what it's asking for in part A, the observation point during t sub 1 to t, so during that time interval. Okay, so let's go ahead and look at part B. Part B tells us that the flow rate is recorded at 15-minute intervals between 7 and 9 a.m. Estimate the number of cars using the highway during this 2-hour period. So here's our table. Okay, and so what we're going to do is we're actually going to use a left and a right Riemann sum. The left, remember, is going to include all of the values except for the last one. So let's look at how this is set up. Okay, we know that the interval, it's every 15 minutes, but that's consistent all the way through. So our delta x is going to be a quarter. It's a quarter because 15 minutes is 1/4 of an hour. And so then what we're going to do is add all these endpoints up all the way and skip the very last one, the 542. So you're going to have 1044 plus 1297 plus 1478 plus 1844 plus, I'm not going to fit all this in, plus 1451, 1378, 1155 plus 802. Remember, we stop at the end there. So it's all these values and you stop at the last endpoint. When you take that, you get approximately 2612. The right endpoint, the right Riemann sum, is going to be all of these values except for the first one. So you're going to use all from 9 a.m. basically to 7:15. We're going to leave the left endpoint off. Same thing, 0.25. And you're going to add the sums starting with 7:15 to the end because we're skipping this one with the right Riemann sum. So that would start at 1297 plus 1478. Plus 1844 plus 1451, going to run out of room, plus ... and we go to the last one, 542. You take all these sums up from here to here and multiply that by a quarter, and you get approximately 2,487. Okay? You can estimate that average now, okay, by taking the integral from 7 to 9, because that's what they wanted in part B, 7 to 9 a.m., of q of t dt, and that's going to equal 1/2 of the right Riemann sum plus the left Riemann sum, which is going to be equal to approximately 2,250. So that's how many cars went on the highway between 7 and 9 a.m. So if you have any questions or comments, let me know, and we'll see you next time.